Today we are going to talk about how generative AI like ChatGPT get to understand or are trained. Before a large language model knowing anything or being trained, the large language model assigns each token. A token, you take it like, for now you can take it like a word. It's like, for example, this one, a sentence is broken down into tokens. I love apple. I love cows. Let me first. For example, I love cows. This is a token. The LLM assigns each word or each token. Let me use a word. Each word with a random group of characteristics with any meaning or characteristic with a group of characteristics. For example, the word I love cows. The large language model can say, can first give it a characteristics, which, like, for example, 20% living thing, 60% edible, randomly end up, because we know an apple is a living thing, but is rating 20% and 50% moving. Can an apple move? No. This makes this work at start, the random work, being meaningless. It is rating, let me continue. It is rating, for example, among the characteristics of a cow, 0% living, and a cow is a living thing, we know that. And we want to know, how will this large language model now come to know that a cow is a living thing? It is showing it is 0% edible. And cows are eaten, that is people's food. 50% moving. Now, the large language model uses the characteristics are more, very many, like very many characteristics. It assigns at first, but randomly. But these characteristics are not written like how I have written them. Instead of rating 20%, it can rate like 20 out of 100 is what? It is a 0.2. 0.2, according to math, this 0 cancels here, get 0.2. And it rates 0.2, and here 60 0.6, and 50 0.5, and forms a vector, a very long one, a vector. It rates a vector which has 0.2, 0. And for a cow it is 0%, and this one gives us in 0.0, 0% edible. The order matters. The first vector for my large language model, it is always going to be talking about the characteristic of living thing. Is it something living? Is it a living thing? And the second vector will always be talking about the edibility. Just I'm bringing a sample, but the language model is more sophisticated, it is more complex. And the third one is always going to be talking about the characteristic of moving. As we continue, these characteristics for it, the large language model, it assigns them in this format of a vector format. Now it is 0.0. It shows the strength. This vector shows the strength of what? Of something to a characteristic. As we know, the first vector is for always, according to this large language model, it is for living thing. And for this, the second one, even if you don't see here, it is for edibility. For this example, I've not said for every example, depends on the large, but the order remains the same for all. Remains the same for all words. The order remains the same for all words. Now we are continuing. This one is the order remains the same. Now we have seen the large language model. At first, it randomly assigns meaning, characteristic, a group of very many characteristics to every token, but these characteristics are meaningless because they are not the ones just did randomly. Even you, when you do something randomly, it is likely to be very wrong. And you see the characteristics, they are not by coincidence, just by that to become correct. How does a large language model move to get correct answers, to understand, it will, for example, it will learn this language, it will depend on the training data. The data that they are using to train this large language model is the one that will shift these vectors to go to change to be correct depending on the data this large language model is being trained on. For example, how does it learn? For example, if it is learning from the training data and it finds a statement for example, when in the training it finds a word that shows the cow died, and we know all living things do what? They have to die. Therefore, this gives a vote to what? To the vector, to the percentage, to the strength of the first of living things. It was 0.0, it was 0%, but now we have seen something that it died. Therefore, this thing is not true, because living things are the only ones that die and showing 0%. It means this has to shift, because living things don't do living things are the ones which die and had given a wrong characteristic. For a car, this therefore on the side of the cow it will increase. It will shift by increasing the what? It will shift by increasing the by increasing the value of this first value, which shows living or non-living. And when it finds we were in the training data, we were a sentence saying we were sleeping and we ate a cow. Therefore, the cow is edible. How does the large language model put 0 on the what? On edibility. Therefore, it has to shift, to change as we include. But it does this very many times. Very many times. What means these wrong answers at the end, they are converted. They shift, keep shifting, keep studying on that, depending on the vector, on the data. Keep studying. At the end, this shift, these dimensions, these characteristics, they shift. Therefore, when if you type a cow, it will be knowing that it is living. It will give here, let me say 100%. Therefore, in the vector, it can be like in the value of the first value can be like 1 after learning. And this edibility also, we know cows are eaten, very much eaten, and it will shift. Let us say it may change to also 1 also, or 0.9, anything depending on the training data. 0.9, and if moving, the cows move, but the apples don't move. It will be studying from the data and shifting. It repeats this. Yes. Some bonus knowledge, some more knowledge. This as we are talked to these values that form the vector, because they are called dimensions. They are called dimensions. Like 0.0 is a dimension. They form a vector, a very long one. Just this is a short. I've brought it for understanding. Subscribe and like the video.